You clicked because you heard that artificial intelligence has become more expensive than human labor. That claim is real, but the math behind it is far more complex than a simple price tag. The real story is not that AI is too expensive, but that the entire economic model of intelligence is flipping from paying people to paying electricity. By the end of this, you will understand the exact revenue threshold where a machine becomes cheaper than a junior employee and why that shift is redefining the future of work. For decades, the dominant assumption in technology was that software was labor-intensive. You build a system, you hire engineers to write code, and you pay them salaries to maintain it. The cost of scaling was linear. If you needed more capacity, you hired more people. If you needed more intelligence, you trained more models, which required more human effort. That model worked for the first 50 years of computing. But the arrival of frontier large language models shattered that linear relationship. Recent analyses from Epoch AI and Stanford University have quantified the sheer scale of this shift. Training a single frontier model like GPT-4 now incurs compute costs that significantly exceed human labor expenses, with estimates ranging between $30 million and $40 million for the training run alone. To put that in perspective, that is the cost of a small city's annual budget, or the salaries of hundreds of engineers for a decade, all concentrated into a single training event. This is not just a line item in a budget. It is the primary economic bottleneck of the entire industry. Here is the thing that changes everything. The cost structure has inverted. We have moved from a labor-intensive model to a capital-intensive one. The massive energy consumption and resulting e-waste associated with AI training create hidden environmental and operational costs that are often overlooked in initial budgeting. When you train a model, you are not paying a developer to think. You are paying for the electricity to run thousands of graphics processing units, often for weeks on end, while cooling systems work overtime to prevent the hardware from melting. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This shift forces organizations to prioritize energy efficiency and hardware utilization over raw developer headcount. The industry's profitability is now highly sensitive to energy prices and hardware supply chains rather than just software development cycles. If the price of electricity rises by 10%, the cost of intelligence rises by 10%. If the price of a junior developer rises by 10%, the cost of intelligence remains unchanged. This fundamental difference creates a new variable in the business equation. Let us look at the specific numbers that define this new reality. While training costs are astronomical, the operational costs tell a different story. Research by MIT researchers indicates that inference costs are deflating rapidly due to algorithmic and hardware efficiency. This suggests a divergence between training and operational expenses. You pay a fortune to build the model once, but running it becomes cheaper every year. This brings us to the critical question of when AI becomes cheaper than human workers. The answer lies in the marginal cost of scaling versus the fixed cost of talent. A junior employee costs roughly $60,000 a year in salary, benefits, and overhead. They can write code, debug issues, and handle customer support. But they have a limit. They need sleep. They need vacations. They get sick. Now consider the marginal cost of compute. If you have already paid the $30 million to train the model, the cost of running that model for an additional hour of inference is measured in fractions of a cent. As long as the volume of work exceeds a specific threshold, the machine wins. The literature presents a nuanced landscape where the break-even point is not a fixed number but a function of scale. For a task that requires constant, high-volume processing, the machine pays for itself in months. For a task that requires rare judgment or creative nuance, the human remains superior. The current economic model relies heavily on massive capital expenditure on GPUs and power. This makes the industry's profitability highly sensitive to energy prices. But once the capital is sunk, the marginal cost of intelligence approaches zero. This is why the narrative that AI is strictly more expensive than human workers due to compute alone lacks direct support in the available academic and technical reviews. The focus is on the extreme capital requirements for training and the complex interplay of energy, efficiency, and regulatory accounting. The real insight is that the cost of compute is far beyond the costs of the employees only in the initial phase. Once the model is trained, the cost of compute becomes the dominant variable. But it is a variable that scales differently than labor. As AI capabilities scale, the cost structure is fundamentally changing. We are seeing a shift where the primary constraint is no longer the availability of talent, but the availability of power and chips. Regulatory papers emphasize that while compute metrics are critical for governance, they are often used as proxies for capability rather than direct cost of labor comparisons. This means that when we talk about the cost of AI, we are often talking about the cost of energy and hardware, not the cost of intelligence itself. The future of this industry depends on algorithmic efficiency. As improvements continue, the cost of inference will continue to fall. This suggests a future where running models becomes cheaper even as building them remains expensive. Organizations that can absorb the initial training cost will find themselves with a competitive advantage that scales infinitely without the need to hire more staff. This is the new economic reality. The cost of compute is far beyond the costs of the employees, but only because the cost of compute is the cost of the future of intelligence. The question is no longer whether AI is cheaper than humans. The question is whether you can afford to build the model in the first place. The answer determines who leads the next era of technology. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.